Look at a typical congested warehouse floor. Forklifts are navigating choked aisles, and inventory is tucked into every available corner. It looks like a facility that has reached its absolute capacity. But in most cases, the space is simply under-optimized. This happens because of SKU proliferation, leading to honeycombing, a process where storage slots are only partially filled, creating invisible gaps in your storage density. When operations managers face this gridlock, the instinctive reaction is to scout for new real estate or break ground on a costly facility expansion. But prioritizing a new commercial lease in a high-demand area, like Eastvale or Anaheim, without maximizing your existing vertical space creates an unnecessary financial drain on your margins. This comparison table shows exactly why. We have to shift our focus from measuring flat square footage to calculating cubic volume, the total usable space from the floor to the ceiling. Warehouse A focuses only on floor space. By leaving the vertical air completely empty, half the building's potential is wasted. Warehouse B treats that cubic volume as a financial asset, building upward to turn dead air into revenue-generating pallet positions. This creates a massive drop in the cost per pallet position. By yielding more storage out of the exact same lease, you distribute your fixed overhead across a much larger inventory. Capturing this capacity requires aligning physical infrastructure with the physics of your inventory flow, the geometry of your products, and the geology of your location. The upfront capital expenditure required to design and install vertical systems is significantly cheaper than taking on the long-term total cost of ownership of an entirely new building. Look at this inventory flow decision tree. The first constraint to solve is how your inventory physically moves through the building. If you handle date-sensitive perishables, like food and beverage products, you are locked into a first-in, first-out, or FIFO workflow. Pallet flow and carton flow systems use inclined rails and gravity to do the heavy lifting. You load from the back, and the oldest product automatically slides forward to the front pick face. The trade-off is spatial. Because these gravity systems require a dedicated loading aisle at the rear, you sacrifice some of your total raw storage density to maintain strict date rotation. For bulk, uniform goods, like auto parts, where expiration dates aren't an issue, you can switch to a first-in, last-out, or FILO setup. With pushback or drive-in racks, forklifts load and retrieve pallets from the exact same side. This eliminates interior aisles entirely, allowing extreme storage density. Selecting the wrong system guarantees you will either throw out expired, unreachable craft or overpay for aisles you didn't actually need. Then there's the geometry problem. Standard racks hold standard pallets, but operations often struggle with non-conforming, bulky items like lumber, steel bars, or long pipes. Leaving these 12-foot materials floor-stacked eats up critical footprint and creates tripping hazards for your workforce. Cantilever racking removes these items from the floor. By relying on a central spine with extended arms instead of front vertical columns, there is no limit to the horizontal length you can store. But this structural freedom comes with operational requirements. Cantilever systems demand highly specific aisle widths and specialized material handling equipment to safely load and retrieve wide inventory. By dedicating specific racks to these unstorable items, you instantly reclaim valuable floor space for your standard high-density pallet storage. A high-density warehouse is a high-contact environment. Forklift strikes on structural columns are frequent and cause compounding damage over time. Hot-rolled structural pallet racks from manufacturers like Fraser act as a physical insurance policy. The heavy-duty steel withstands aggressive strikes much better than standard roll-formed racks. This durability means a higher initial procurement cost and heavier shipping weights, but it drastically reduces future repair cycles and operational downtime. The physical environment extends beyond the warehouse walls. Operators in Southern California regions like Mira Loma or Anaheim must build around serious geological constraints. High-pile storage in high-velocity seismic zones carries the very real risk of catastrophic structural collapse or immediate legal closure if you fail a municipal inspection. This is where two BRAC systems become necessary. Their closed-section, high-strength steel tubes actively flex to safely dissipate kinetic energy during an earthquake. To deploy this correctly, you have to navigate rigorous upfront seismic engineering and complex local permit management for high-pile storage. Investing in impact-resistant and seismic-compliant engineering upfront prevents massive operational downtime and protects your legal right to operate. The absolute limit of cubic volume optimization requires moving beyond static steel and integrating multi-level mechanical automation. Automated storage systems, like modular vertical lift modules and custom pick modules, can quadruple your picking footprint within the exact same square footage. These vertical lifts reclaim massive floor space by sending inventory right up to the ceiling and bringing it back down directly to the picker. To make this work, a robust warehouse management system must act as the digital brain, ensuring the physical hardware and robotics move in a perfectly timed sequence. This level of integration requires significant capital expenditure and a meticulously managed digital implementation phase so existing workflows aren't disrupted. Once synchronized, this technology bridges the gap between high-density storage and rapid retrieval, turning a stagnant storage room into a high-speed fulfillment engine. We can map these trade-offs using this scorecard matrix, linking specific rack solutions directly to your operational profile. For a food and beverage or e-commerce operator, the strict constraint of inventory obsolescence makes pallet flow and carton flow systems the right choice. A heavy industrial or bulk auto parts distributor needs extreme density and impact durability, making pushback or drive-in structural systems from Fraser the best fit. And for a Southern California operator fighting high real estate costs, the solution is maximizing vertical space with tube rack and rigorous seismic permit management. Applying the correct infrastructure stack based on these constraints is the most reliable way to lower your total cost of ownership. The blueprint for growth isn't expanding outward, it's harvesting the vertical space you're already paying for. If you're operating in Southern California or Nevada, Southwest Warehouse Solutions can conduct a comprehensive facility design audit. You can call their engineering team directly at 951-360-7087 for expert guidance on maximizing your operational capacity. Visit swwarehousesolutions.com/contact or check out their Google business profile to explore their full material handling and automation catalog. Stop fighting for every square inch of floor space. Integrating vertical solutions with the right engineering partner ensures your warehouse operates as a high-functioning engine of commerce.